All right, so I wanted to look at an example with you and just think together about the various aspects of this. So here's a function that I'm handing you, and I'm going to ask us to think about whether or not it's one-to-one, first of all, and then if it is, to find its inverse, so on and so forth. And so there's really two ways, given a function, that you can tell whether or not it's one-to-one. One is to actually use the definition, which we'll practice doing at some point. But in general, if you know the graph of the function, you can do a mind picture sketch of this function just in your mind and think about whether or not it passes the horizontal line test. And so the key is that you know what x cubed looks like. X cubed looks something like that. You don't need a perfect graph. What does the 3 do? That's a vertical stretch. What does the minus 5 do? That shifts it down. The point is, that's the shape of the function. This is one-to-one. So just from the horizontal line test, you can tell that f is one-to-one, we'll say, by the horizontal line test. Okay, so now I want to think about finding the inverse function. Before I do that, though, I want to point out a couple of things to you. So, for example, I can compute, let's actually ask this. Let's say, what's f inverse of 19? What's f inverse of 19? And so I don't know what f inverse of 19 is, but I know that it exists because f has an inverse function. I'm going to call it c, and I realize that my definition above says whatever f inverse sends 19 to, which we're calling c, you know f has to send c back to 19. I look here and I realize, hey, if I plug in 2 for x, I get an 8 times 3 is 24 minus 5 is 19. Oh look, f of 2 is 19, so then you know c has to be 2. And so the point is f inverse of 19 equals 2. Now, why did I do that? I wanted you to realize that you can compute values of the inverse function without actually having the full-blown formula. Right? I was able to figure out what f inverse of 19 was without having the full-blown formula. Now, let's find the full-blown formula. So how do you do it? So if we want to find the general formula for f inverse of x, what do? Well, here's my little, I'll put this in a different color. My little advice for you is, 1, you want to reverse the roles of x and y, and 2, you want to solve for y. All right, so what am I talking about? So I'm going up here. I'm thinking of f of x is y, and so I have y equals 3x cubed minus 5. I haven't done anything yet. I'm going to reverse the roles of x and y, so I'm going to write this as x equals 3y to the 5th minus 5. Now I've done the first part. That's just quite literally switch x's and y's. And then I want to solve algebraically for y. And so I can say, well, I get x plus 5 equals 3y to the 5th. And so that means what? X plus 5 over 3 is y to the 5th. And so y is going to be the 5th root of x plus 5 over 3. And so that's it. Wait, how did I get a 5? Oh, I had a 3 here. And I made it a 5. I don't know how I did that, but I did. So let's put that all back. This is cubed. This is cubed. This is cubed. And that's cubed. There we go. So there it is. There's our inverse function. And of course, you can plug 19 into this, and you're going to get 24 over 3, which is 8. Cube root of 8 is 2. You can figure out f inverse of 19 just using your formula directly as well. So I want to run through just a list of properties of one-to-one functions and their inverses. So here we go. So properties of one-to-one functions and their inverses. Some of this will be familiar to you as review. Some of it won't be. Let's start out. We'll do maybe 2 or 3 of these, and then I want to switch and break the video here. So the first one we've already seen is that the domain of f of x is equal to the range of f inverse, always. And of course, the range of f of x is equal to the domain of f inverse of x. That's the first one. The second key property is that you always have f of f inverse of x. When you compose a function with its inverse, that's just x, as long as this is for all x in the domain of the inside function, which is f inverse. It's always the domain of the inside function. This symbol means for all. So I'm saying for all x in, this is the in symbol, the domain of the inside function. So whenever you see this, this expression always reduces to just x, as long as x is in the domain of this guy. And then it shouldn't surprise you that f inverse of f of x always composes to x for all x in the domain of f of x. All right, well, let's break this video here, and then we'll keep going with these properties in the next video.